Okay, review time. You got to simplify the following square root expressions. You got the square root of 300. Now, 300 is not a perfect square, so we label that an irrational square root. We put the division sign in, and we see which one of the perfect squares that 300 divides by. So I think you try 289, but you know that probably doesn't work. 256, nope. Nope. No on 196. Nope. 144, no. 121, nope. And then 300 is going to work because it'd be the square root of 100 times the square root of 3. Okay, so the square root of 100 then turns into 10, and we now have 10 times the square root of 3. Okay, now the next problem, you have the square root of 128, but it's also multiplied by x to the third. So, make a square root, okay, but we're going to split the multiplication up into two separate square roots, which you are allowed to do. Got the square root of 128, and then we're going to have the square root of x to the third. So the square root of 128 is irrational. So we put in the division sign, and we see what 128 is divisible by. 121, nope. 100, nope. 81, nope. Okay, it's divisible by 64, so it's the square root of 64 times the square root of 2. Of course, the square root of 64 turns into 8. So 8 times the square root of 2. So we put 8 on the outside and 2 on the inside. Now the square root of x to the third, remember that means x times x times x. And we manipulate and we break the square root down to even more square roots so that they cover 2 x's at a time. So square root of x times x. And then that x will remain in its own square root. But right here, we have x times x, which is x to the second. Then the square root and the second cancel, and that gives me x. Okay? So we have one full factor of x, and then a square root of x. Okay? So we're going to have x outside and x inside. So 8x times the square root of 2x. Okay, the next problem, we got the square root of 5x to the fourth times the square root of 15x. Square root of 5x to the fourth times 15x. So again, that's the square root of 5 times x to the fourth, and the square root ends, and then times 15 times x. So this is all multiplication, including between the square roots, okay? So, 1, 2, 3. Okay, a multiplication has 3 processes. Okay, the first thing you want to do is multiply the outside coefficients, but there are not any. So you multiply the inside of the square roots. You find the inside product of the square roots. So 5 times 15 is 75 times, and then x to the fourth times x is x to the fifth. Okay. Now you simplify your new square root. You see how much of that you can get out of the square root. So you got the square root of 75, and you got the square root of x to the fifth power. Okay, so the square root of 75, is irrational. So we put in the division sign, and then we start seeing what goes into 75 as far as perfect squares go. So 75 divided by 64 is a decimal. Divided by 49 is a decimal. Divided by 36 is a decimal. Divided by 25 is not a decimal, so we rewrite that as the square root of 25 times the square root of 3. With the square root of 25 changing into 5. So 5 times the square root of 3. So we have 5 out, 3 in. Okay, so x to the fifth, x times x times x times x times x. So we break up that so it covers two of them at a time. So that x there will remain in the square root. So x times x, x second. Square root and the second cancel, giving me x. Same thing happens here. X times x, x second. Those cancel, giving me x. And then we got the square root still of the solo x, which does not cancel. So we multiply these outside x's. X times x is x to the second, and then the square root of x. So x to the second goes outside with the 5, and x goes inside. Now the third step is simplifying the outside if you can, but we really can't because x we don't know. Okay, it's just 5x times x to the second power times the square root of 3x. Okay, next problem. We have 7 times the square root of 3 plus 10 times the square root of 108. Now, how do we do the addition? Well, with addition, we have to get like terms. See, the 7 and the 10 are not like terms because the 7's multiplied by the square root of 3 and the 10's multiplied by the square root of 108. So something needs to change so that the outside coefficients are multiplied by the same square root. So we accomplish that by making a table. Or try to accomplish it. It doesn't always work out. So 7 times the square root of 3, and then 10 times the square root of 108. Okay, now the square root of 3 is irrational. So a division if you want to drop the 7, but the thing is, when you look at the square root of 3, the only thing that's going to go into the square root of 3 is the square root of 1, which is pointless to do. So that is already in simplest form. 7 times the square root of 3. Okay, then 10 times the square root of 108. Now 108 is an irrational square root, but that's a lot bigger irrational, so there's probably something that's going to divide by the 10 just drops. So 108, we would divide that by 100, doesn't work. And 81 doesn't work. 64 doesn't work. 49 doesn't work. It is divisible by 36, so it is the square root, oh, sorry, do that up here. Square root times square root, 36 and 3. Sorry about that. So square root of 36 is 6, so instead of 10 times the square root of 108, we now have 10 times 6 times the square root of 3. And then 10 times 6, of course, is 60 times the square root of 3. So this goes from 10 times the square root of 108 to 60 times the square root of 3. They're equivalent expressions. The 60 times the square root of 3 is in simplest form. So now the 7 and the 60 are the outside coefficients, and they are like terms because they're both multiplied by the square root of 3. Okay? So 7 plus 60 is 67. Okay? And you can only add terms in algebra if they're multiplied by the exact same thing. Okay, rationalize the denominator. Okay, we have 7 divided by the square root of 5. Now remember, when you have to divide, okay, to divide this, you need to get rid of the square root in the denominator. Okay, and there's a square root of 5, nothing else is being added to it, so the equivalent fraction I multiply is just the square root of 5 on bottom. And then, of course, to maintain fraction equivalence, we also have to multiply the same thing on top by what we're multiplying by on bottom. So again, this should be equivalent to 1. Okay, when you have same numerator, same denominator, that's always equivalent to 1. Okay. Okay, and I'm just going to simply multiply this here. Or actually, here's where my answer is going to be. Okay. So I like to put 1s maybe in front here. So this is just 7 times 1 times the square root of 5. That's your top. Okay. Now the bottom, if you want to put 1s, you can. 1 times the square root of 5. So this is just 1 to 1. So 1 times the square root of 5 times 1 times the square root of 5. So 7 times 1 is 7, and then times the square root of 5. and then 1 times 1 is 1. The square root of 5 times the square root of 5 is the square root of 25. Now, let's see if these simplify. So on top we got 7 times the square root of 5. And then from the bottom we got 1 times the square root of 25. So the square root of the number 5 is irrational. And the only thing the square root of 5 really goes into the square root of 5 is 1. Okay, so that'll just stay the same. So that's your numerator, 7 times the square root of 5. But on bottom, the square root of 25, remember the whole point of this was to get rid of the square root from the bottom. Now the square root of 25 is not even irrational, it's equal to 5. So we have 1 times 5, and that equals 5. Okay. So 1 times 1 is 1, square root of 25, square root of 5, and then that's finished right there. Okay. Alright, number 6, 3 divided by the square root of 3 plus 5. Well, first off, again, the whole thing is to get rid of the square root from the denominator. Okay, it's called rationalizing the denominator. Now we got a square root of 3, but there's a 5 being added to it. Okay, so when there's something being added to that square root, we can't just multiply this by the square root of 3. Okay, you parenthesize that and you use the conjugate rule. Remember, the conjugate rule is when you multiply, okay, by the conjugate of this expression here. So you keep the first square root, the first term the same, the square root of 3 plus, but then the second term you make into its opposite, so negative 5. And then if you basically copy the same numerator and denominator have to match here, so that it's a fraction equivalent to 1. Okay, now find these products. Okay, so this one, 3 to 1, 3 to negative 5. So we're taking 3 times 1 times the square root of 3. Again, here's the plus. Okay, you see the plus. So 3 times 1 times the square root of 3, and then 3 again to the negative 5. Now I will figure that out in a second. Now I'm going to set up my bottom. So 1 times the square root of 3, 1 times the square root of 3. Now here's my pluses. Okay, pluses kind of help you see where to distribute. So 1 times the square root of 3 times 1 times the square root of 3. And then 1 times the square root of 3 times negative 5. Then that's the end of that. Now 5 times 1 times the square root of 3. And then 5 times negative 5. So now find your products. So that's 3 times the square root of 3, and that's negative 15. 1 times 1 is 1 times the square root of 9. 1 times negative 5 is negative 5 times the square root of 3. 5 times 1 is 5 times the square root of 3, and then negative 25. Okay, now on top we got 3 times the square root of 3 and negative 15. On bottom we've got 1 times the square root of 9, negative 5 times the square root of 3, positive 5 times the square root of 3, and then negative 25. Okay, so the square root of 3, well, it's an irrational square root, but the only thing that really goes into the square root of 3 would be the square root of 1, which means I'm just going to keep it as a square root of 3. Okay, and then this is already in simplest form. There's no square root. So you got a 3 and a negative 15, but this is multiplied by the square root of 3, and this is multiplied by nothing. Okay, so we keep that the same. There's your numerator, 3 times the square root of 3 plus negative 15, or minus 15. Okay, now before we look at this, with the conjugates on the bottom, look at these two. These two are the exact same, except you have a negative and a positive, so they cancel. Okay, there's no point in dealing with them when you have a negative and a positive, the same thing. They're conjugates. When they're added, they equal to 0, meaning they cancel. Now the square root of 9 is equal to 3. Okay, so 1 times 3, and that's 3. And then negative 25, yeah. So then I add the 3 to the negative 25, and that's negative 22. And there's your denominator. That's your answer. Okay, that one's probably the biggest pain on the whole thing. Okay, now the next one, your idiot teacher didn't write directions. You're supposed to solve the equation, meaning you're solving for x. Okay, so remember, the x variable I'm solving for is inside a square root, so it's a two-step process that we talked about. You're going to solve for the square root, then you're going to solve for the x. Okay. Square root's over here. Do you have any numbers outside the square root over there? No, you don't, so you go right to your second power, and that'll eliminate the square root. Okay. So second, cancel that, and you got 3x plus 1. And then 5 to the second's easy to find. It's just 5 times 5. Okay. And that's equal to 25. Now, before you solve for the x, you look at the equation, you got x only. So if it's x only, you're using linear properties. There's one answer. Linear properties, when you use inverse operations, you get the x variable by itself. So you got times 3 plus 1. So minus 1, that's 24. And divide by 3, and that's 8. Okay, easy enough. And again, the reason why that works the way it does, because if you have the original equation, here, I'll write it here. We put 8 where the x is at, so it's going to be 3 times 8 plus 1 equals 5. So within the square root, 3 times 8 is 24. 24 plus 1 is 25. So the square root of 25 equals 5. Well, yeah, the square root of 25 is equal to 5. So yeah, that's right. Okay, number 8. The square root of x plus 5 equals 16. So solve for your square root, then you solve for your x. Okay, so the square root's on this side. This time there is a number outside the square root. It's a plus 5. Okay, well, you get rid of a plus 5 with a minus 5. Then you'll get rid of the square root with the second power, and then the square root will be solved for. So first we need to subtract 5. That's going to be 11. So the square root of x plus 5. Then use your second power to eliminate your square root. And that's a value we can find the second power for. 11 times 11 is 121. Now you solve for x. Again, it's x only. Then you're using linear properties. There's one answer. Okay. So you minus the 5 from both sides, and that's 116. Okay, next problem, 3. The square root of 4x plus 1. 3 times is what that is. The square root of 4x plus 1 minus 2 equals 25. Okay, so solve for your square root, then solve for your x. Okay. So square roots on this side, there's two numbers outside. You got a times 3 and a minus 2. You have to get rid of the minus plus number first. So you're going to get rid of the minus 2 first with plus 2. Then you get rid of the times number, which divide by 3, and then you use your second power. When you have two numbers outside of the radical like that, okay, you get rid of the number with the minus or the plus first, and then the divide comes next. So first we plus 2, and that's 27. So we have 3 times the square root of 4x plus 1. Okay, done. Now divide by 3. 27 divided by 3 is 9, and you have the square root of 4x plus 1. Okay. Now second power will take out our square root for us. So that cancels, and we have 4x plus 1. Then of course 9 to the second, that's easy. You can find that. It's 81. Okay. And now it's time to solve for the x. Okay. So you got x only. Linear properties, there's one answer. Okay. So So you got times 4 plus 1, so you subtract the 1, it's going to be 80. And then we divide by our 4, and that's 20. Okay, then the last one of these, again, you're solving an equation where that variable is in a square root. It's also over here outside of a square root, but we got to focus first on getting it out of the square root. So, solve, number 1, solve for the square root. Number 2, solve for the x. Okay. Okay, so the square root's on this side. Nothing outside of it, so we go right to our second power. Okay, 3x. Now over here you don't get a cancellation, but you see you can't just you can't find what that is to the second power because you have that unknown x value. So then you get rid of the second and then you make a parentheses off to the side just like it, x minus 6. So we need to find what x minus 6 times x minus 6 is. Now, you put 1's in front, and this is a binomial. The 1's multiplied by x, the 6 is not, and then the same thing over here. So you have to execute the FOIL method to find that product. So 1x to 1x, 1x to negative 6. That's the end of that. Then negative 6 to 1x, negative 6 to negative 6. Okay, so this is 1x to the second, negative 6x, negative 6x, and positive 36. Okay, so you get x second, x constant. So x second is 1, negative 6 plus negative 6 is negative 12, and then 36. So bring that over here. Okay, now it's time to solve for the x. But we have lots of x's. We see x is to the second in this equation, and it's also to the first. First meaning just x. So you're using the factoring properties, not the linear properties. So there's two answers. And to use the factoring properties, you need to clear one side of the equation. Clear the side that doesn't have the x to the second. Now, I don't need to hang the 3x because we have this negative 12 here multiplied by x. Okay, now you got your 0. Now you got your x second, your x, and your constant. So you have 1, negative 15, 36. Okay, now you see your trinomial, and you go GCF t-table to make it into two binomial parentheses where you can use the factor 1, factor 2. Okay, 1's a GCF, so you don't have an x, you don't have a negative, it's just 1. So 1 times 36 is 36, positive. So it's a match. And it has to add to negative 15. 136, that's negative 37, nope. 36 divided by 2 is 18, and that's negative 20, so nope. 36 divided by 3 is 12, and there's your negative 15. Okay, so a is 1x to the second power, so x times x. And then 1 and 1. Now those don't simplify. Never does when the coefficient's 1. Again, the 1 times a 1 should equal what's in front of the x second. It does. Negative 3 times negative 12 should equal what the c is, and it does. Now we really don't need the 1's in front of the x's, so we're going to have x minus 3, x minus 12 equals 0, then f1, f2. So minus 3 could equal 0, x minus 12 could equal 0. So we add 3, we get 3. And we add 12, and we get 12. 3 and 12. Okay, now the last few problems are some geometry type problems. Calculate the distance between the points, okay? Remember, you don't draw this, but I'm just showing you what you're finding, okay? 2, 1, and then 3, 7. You're trying to find how many units it is from this point to this point. Remember, it's like the Pythagorean theorem, but there's an easier formula to use. Distance is the square root of parentheses plus parentheses, x minus x to the second plus y minus y to the second. So distance equals, okay, now we're just going to substitute for the x's and the y's, okay. X minus x, well, I'd start with my higher x. By the way, you put a 3 here and a 7 here, because that's x, that's y. Now for the minuses, you're going to put a 1 here, or excuse me, a 2 here, because x minus x, that's 2. And then y minus y, well, the other y is a 1, okay. So 3 minus 2 is 1, 7 minus 1 is 6. Okay, so we have 1 to the second plus 6 to the second. Now what are those numbers to the second power? Well, 1 to the second is 1 times 1, that's 1. 6 to the second, 6 times 6, and that's 36, okay? Sorry about the phone ringing in the background. And then we have the square root of 37, okay? Now the square root of 37 is irrational, it is not a perfect square, okay? So 37, what's that going to put in the division sign? What's it going to divide by? So 37 divided by 36 decimal, divided by 25 decimal, 16 decimal, 9's a decimal, 34 doesn't go in it, so it's just 1. So if it's just 1, just keep it the same. It's pointless to divide by 1. So the answer is square root of 37 units. Okay, and that's how you find the distance. Okay, number 12, calculate the midpoint of the segment connecting the points. Okay, now you're finding something different. You're finding the midpoint. Okay, so again, don't draw this coordinate plane. I'm just showing you what you're finding. So negative 12, 12. I go back 12, 12 would be all the way up here. Then 14, negative 4, 14, negative 4. So it's a segment, but I'm not finding the distance. I'm not finding how far it is from here to here. I'm finding the midpoint. Okay, so M equals, the midpoint is a coordinate, okay? You simply find it by adding your x's and dividing by 2, and then adding your y's and dividing by 2. Okay, so xy, xy. So the x is negative 12 plus 14. And then the y's is 12 plus negative 4. It doesn't matter the order you do addition, okay? So negative 12 plus 14 is 2. And 2 divided by 2 is 1. 12 plus negative 4 is 8, and 8 divided by 2 is 4. So 1, 4 is the midpoint, okay? So these problems look the same, but you got to read the directions. Now the last one, you're finding the third side of a right triangle. Of course, that's the Pythagorean theorem. A squared plus B squared equals C squared. So in this, A is 9 to the second. B, that's 40 to the second. And then the C is what we're trying to figure out. So find what these numbers to the second are. 9 times 9 is 81. 40 to the second, 40 times 40 is 1,600. C to the second. Now we solve for the C to the second using linear properties, but you see the C to the second's by itself already. I don't have to add or subtract anything. I am going to have to do the square root to get rid of the second power, but first I need to add these two. So 18 plus 1,600 is 1,681. And now square root. Now before you sit, you don't know if it's irrational or not because our list doesn't go that high. So what you'll do is square root it on the calculator, and if you get a whole number, it's not irrational, it's 41. Okay. So I don't start dividing, I just put 41. There's your answer for C. Okay, next one. I don't have these labeled. You don't really need them labeled, to be honest with you. Okay, I mean, C is always the hypotenuse across from the 90-degree angle. Okay, then A and B, or B and A. If you get A and B mixed up, it doesn't really matter. Okay, so A is what we don't. A to the second plus B to the second equals C to the second. So A, don't know A. B, we know B is 40 to the second. And then C, we know is 41 to the second. Okay, so we keep that in variable form. 40 to the second, 40 times 40, that's 1,600. And then 41 to the second, that's 41 times 41. And 41 times 41 is 1,681. Now I solve for the A using the linear properties, but we have to take out the 1,600 by subtracting it. A to the second, 1,681 minus 1,600 is 81. Now we find the square root of 81. Square root of 81 is not irrational. It's equal to a whole number value. It's 9. So A equals 9.